Okay, so this is a beginning of talking about the binomial distribution. Okay, so in a binomial distribution, this is used to find probabilities that model certain things. One, you're going to do something over and over and over again for a fixed number of times. So there has to be a fixed number of trials. Two, the trials have to be independent. So one trial cannot affect another. Things like coin tosses are independent. Okay, the third one, the trial has to have two possible outcomes. One we will label as a success, and the other one we will label as a fail. Right? So these are the two possible outcomes. And number four, the probability of success on each trial has to be the same. If I meet these four criteria, I have a binomial distribution. Okay, so let's give a quick example of this. Okay, so like if you look at your notes, there is an example in there. I'm not going to write this all out again, where in the example we asked like 5 adults, do you know how to use Instagram, right? And here's my results. So we believe that there's an 85% chance that any given adult knows how to use Instagram, so we're going to ask 5 of them. So what we should expect to have happen is that the probability that none of them know how to use Instagram is like really, really tiny, right? It's less than 1%. That only one would know how to use Instagram is like 0.2%. That only 2 know how to use Instagram is like 2.4%. That only 3 know how to use Instagram is 13.8%. That only 4 is 39.2%, and 5 is 44.4%. So the question is like, where are these numbers coming from, and how can I get them? All right, so we got to establish some notation first. Okay, so when we're doing binomial problems, we're going to use 3 parameters, P, Q, and N. And in fact, Q is just 1 minus P. So this is the probability of success on a trial. So in any given trial, the probability of getting success is P. In our example, the probability of finding an adult who has the ability to use Instagram is 85%. Q then is the probability of failing on a trial. So if any adult has an 85% chance of knowing how to use Instagram, then there is a 15% chance that they will fail. 1 minus 0.85 gets me to 15. And N is the number of trials. And in our experiment, or our example, we said we were going to do 5 trials. Now, there's a formula for this, okay? The formula is that the probability of getting X successes is N permute X times P to the X times Q to the N minus X. Now, good news for you. You don't need to memorize this, okay? So like in our experiment, the probability of getting X trials would be, well, let's see, there's going to be 5 trials, right? And we're going to choose X people. And that's 0.85 is my probability of success times X times 0.15, the probability of the failure, 5 minus X. Okay, so let's say I wanted to know the probability of 3 people getting success, right? This is 5 permute 3. 0.85 to the third, 0.15 to the 5 minus 3, which is 2. Now, that number is going to happen to work out towards about 0.138. If you put it in your calculator, that's what you're going to get. But the problem is having to memorize this formula, and that seems like really cumbersome. So the good news for you is that there is a function in your calculator that does this for you, and you'll never actually have to know that formula. Okay, so here I have my TI-84 calculator, and I want to do that calculation. The probability that if I ask 5 adults, like, do you know how to use Instagram, that 3 of them can. Alright, so here's how I do this. I go to second, and then vars, and if you look above vars, there's a distributions there. And this gives me a list of distributions. And the distribution that I have is way down here at letter A. And it's a binomial PDF. I mean, down below that is binomial CDF. We're not going to use that. We're going to use binomial PDF. All right, in my experiment, I did 5 trials. The probability of success was 0.85. And I want to know the probability that 3 of those adults actually know how to use Instagram. I hit paste. I hit enter. Oops, enter. And it says, there we go. 13.8% of them do. It comes up with the exact number that I want. All right, now if I wanted to build the whole probability distribution, I could do this for like 5 and 3, 5 and 0, 5 and 1, and fill in the table accordingly. But what I want to do is I want to create the whole table all at once. So here's what I'm going to do. I'm going to go to Stat. I'm going to Edit. And in List 1, I'm going to put the possible outcomes of my experiment here. Well, I can have 0 adults know how to use Instagram, 1, 2, 3, 4, or 5. Can't have more than 5. Why can't I have more than 5? Because I'm only asking 5 adults, right? If I had 20 trials, I'd have to go from 0 to 20 to build the probability distribution. Now, I want the probabilities in L2, but I'm not going to do that by hand. So here's how I'm going to do this. I'm going to go back to the main screen. To go to the main screen, I always hit second mode. It takes me back to the main screen. I'm going to do exactly what I did before. I'm going to go second vars. I'm going to go down to A, which is my binomial PDF. My number of trials is still 5. The number of success is now 85. But instead of a specific value here, I'm actually going to do all the values for list 1. Okay, so I'm going to have this operate on the 0, the 1, the 2, the 3, the 4, and the 5. And then I hit paste. And now where do I want to put my results? So I'm going to hit STO, which is down above the on button here. And I'm going to store that in list 2. And blam. Okay, so I go to Stat, Edit, and now in list 2 are all the probabilities that were in my table at the beginning of this all. Okay, now note the first one there is 7.6 times 10 to the negative 5, so that's actually 0.0000, that's 4 zeros, 0.000076, which was the first number in my probability distribution. You can look up in the notes and see that, and the rest of them just fall right in line. There's that 3 at 13.8 again, 39% for 4, and 44.3, well, 44.3, 44.4% for 5. All right, so there you go. That's an introduction to the binomial distribution and how to do it with a calculator.